In this video, I'm going to talk to you about stoichiometry, or mathematical calculations in chemistry, particularly with balanced chemical equations. In this video, I'm going to cover mole-to-mole conversions. This is an example of a problem that is a mole-to-mole conversion problem. It's the simplest kind of stoichiometric problem that we can use with a balanced chemical equation. How many moles of nitrogen gas are produced when 0.050 moles of sodium azide decomposes into its constituent elements? So the first step is to write and balance a chemical equation that represents this chemical reaction. So sodium azide, first of all, is that compound. It's going to decompose, so we just have one reactant, and it's decomposing into its constituent elements, sodium and nitrogen, which when it's all by itself in nature is a diatomic element. Now you go back and balance that chemical equation. And those coefficients tell us the relationship, the quantitative relationship between each of these substances in this chemical reaction. So we can use those coefficients in quantitative calculations. We can use those coefficients to write mole ratios, and in this problem we're relating sodium azide and nitrogen gas. So we have two possible mole ratios, 2 moles of sodium azide and 3 moles of nitrogen is the relationship. So that's 1 mole ratio that we can write, and you can also get the inverse of that. Which one do you use? Well, your units will tell you in dimensional analysis. So you set up your problem and follow your units through, and then you'll know which of these conversion factors you need to use. So I am given 0.050 moles of sodium azide. That's the quantity that I'm given. So that's what I start with. And what I want at the end for my answer is moles of nitrogen gas. That's what it asks me to find. So now I'm going to follow my units through to figure out which conversion factor I'm going to use. I've got moles of sodium azide here, and I want to end up with moles of nitrogen. So I need to put the unit that I want to cancel out on the bottom. And the unit that I want to go to, I put on the top of the conversion factor. So this will allow me to cancel out, because moles of sodium azide divided by moles of sodium azide is 1. So I can just cancel those out. And then I'm left with the unit of moles of nitrogen, which is what I want for my answer. So then I just look at where my units are, and that helps me to determine which of these conversion factors I need. Back with the balanced chemical equation, I see that I have 3 moles of nitrogen for every 2 moles of sodium azide. So that is the correct conversion factor. At this point, then, I just do the math. You multiply the items that are side by side. You divide by whatever is on the bottom. You watch significant figures. These are counted. This is a measurement. So how many significant figures does it have? Well, this first 0 is a leading 0, so it is not significant. This is non-zero, so of course it is significant. A final 0, where I see the decimal, so I know that that's significant. So I have 2 significant figures here, infinite, infinite here. So I'm limited to 2 significant figures in my answer. So you just punch this into your calculator. Basically, this is 1.5 times 0.50. I could probably just figure this out. And then times 1.5. There's my answer to the correct number of significant figures. This is another example of a mole-to-mole stoichiometric problem. How many moles of sulfur dioxide gas is produced when 82.5 moles of oxygen gas react completely with dihydrogen monosulfide gas? And I've even given you the balanced chemical equation. So really this is a very simple problem. We're going to start with what we're given, 82.5 moles of oxygen gas. And then think about what you need for an answer for units. It asks how many moles of sulfur dioxide gas. So in the end equals blank moles of sulfur dioxide. So thinking about the units, I can see that I need to cancel out moles of O2 and then have for my answer moles of SO2. I can go directly from moles of one substance to moles of another substance whenever I have a balanced chemical equation. Put moles of O2 in the bottom of this conversion factor so that I can cancel out moles of O2 divided by moles of O2 is 1. I'm converting the units to moles of sulfur dioxide. That's what I need for my answer units. So that unit goes on the top. It's always a good idea to ask yourself, can I get directly between these two units? Is there a direct conversion that I can do between moles of O2 and moles of SO2? And yes, there is, as long as you have a balanced chemical equation. My balanced chemical equation tells me 2 moles of sulfur dioxide gas is made from 3 moles of oxygen gas. And now you just do the math and round to the correct number of significant figures. Now, for significant figures, remember these have an infinite number of significant figures because we counted them. These are all non-zero, so I know I have 3 significant figures. So although my calculator reads that, I know I need one more digit to make sure that I am showing the correct number of significant figures.